All right, hey guys, my name is Seduraman and welcome to day 9 of 10 days of base. I mean, look at that. Can you believe it? Like, we are almost at the finish line. I mean, let's just take a moment to appreciate what you've accomplished in just like a week, like 8 days. I mean, you've built AI agents that can execute transactions autonomously with Agent Kit. You have crafted front end with on-chain Kit, smooth front end that can even rival like web 2 applications. You have set up paymasters that generously pay for your users gas fee. You have deployed smart contracts, or even you have even created smart wallets that gives users all those crypto superpowers that they didn't know even existed, right? So you're basically a web3 visit, like base web3 visit by now, right? But when you look at all the things that we have built, there is a plot twist. I mean, there is like this there's been like this one tiny little absolutely massive limitation to everything that we have built so far. I mean, all of it lives on a single chain, right? I mean, it's like your beautiful DeFi app only works on Base. Your killer NFT marketplace, Base only. Your revolutionary social app with smart wallets and gasless transaction. It's just base, and more base, right? Now, I mean, don't get me wrong. Like, base is actually pretty good. Like, it's fantastic. I mean, it's fast, it's cheap, it's Ethereum aligned, and we are building on it for a good reason. Like, we built the entire 10 days of base because it is good, right? But let's be real. I mean, your users don't live in a single chain world, right? I mean, imagine this: your potential user Sarah has most of her USDC sitting on Ethereum mainnet because that's where she first bought crypto. Or your friend Marcus has been collecting NFTs on Polygon for the past 2 years. Or your early adopter community from last year, they are holding tokens on Arbitrum, and that whale investor who wants to try your application. I don't know. They got their funds scattered across 7 different chains, like some diversification obsessed guy, right? So here's the uncomfortable truth. I mean, every time someone wants to use your app, but their funds are, and let's say like their funds are on the wrong chain, you're basically putting up a giant sign that says "wrong chain, buddy." It's like putting up that sign at the entrance of your app, right? So once they see the sign, or once they understand that they're using a different chain, they would have to manually bridge their tokens, pay bridge fees, which is annoying and scary, wait for confirmation, all that before they can even try your app. Like, remember how we talked about all the friction just takes away all the users, right? So this is a big friction, and this is the reality. Like, there are a lot of chains, and people use multiple chains. Like, that is the whole point of having a decentralized ecosystem. It's not just about the infrastructure or the chain that you use. Even the ecosystem has to be decentralized in terms of the number of options available to the users. And most users actually prefer different chains for different stuff, right? Different chains have different properties or characteristics that suits different applications, and they go for it, right? So when they see all this bridging, and I mean, bridges itself is scary because of all the exploits and hack. So I don't know, like maybe about 60 to 70 percentage of them will just give up, and just maybe move away from your application. I mean, you can't really blame them, right? Like, asking them to bridge and all before you try, bridge their assets and stuff before they even try out the application is sort of like filling out, I don't know, customs form before entering a theme park. I mean, nobody actually signed up for the paperwork. They are in it for the rides, right? So yeah, I mean, we need ways to actually prevent all that, so that all these assets and all these tokens or whatever can safely move across different chains. And I guess, like, if you look at today's challenge, that's what we are going to discuss. So yeah, let's go. Okay, so listen. You see, the future of Web3 isn't one chain to rule them all. I mean, that actually defeats the purpose of being decentralized, right? Like, if there is one chain, that's basically a centralized stuff, right? So you need chains, right? So the future of Web3 is actually this, beautiful, chaotic, like weirdly interconnected ecosystem where chains like Ethereum, Base, Polygon, Arbitrum, Optimism, Avalanche, and a dozen other chains with like three users all coexist. Each has its own strengths, each has its own communities and liquidity pools and Twitter accounts and everything, right? So it's less like a single highway and more like an archipelago of like islands, each with its own culture and resources. Like you can just go to a website like DApp Radar and see all the different chains, right? Like there are tons of these chains, like lots and lots of these chains that you can just browse through. And even if it's layer 1 or layer 2 or whatever, right? So each of them is like I said, each of them has their own stuff that is going for them, right? Like some of these chains are known for like DeFi projects. Others might be for gaming, and other chains might be like super fast and cheap, right? So if you want to build applications that reaches masses, like you need to embrace this reality, right? You need to, I don't know, build some kind of like bridges between these chains, or better yet, you need to actually build some kind of a teleportation device, right, that can move assets or tokens between these chains. So today what we're going to do is we're trying to break free from this single chain prison, and we are learning how to make your application chain agnostic, right? So that means how to let your users interact with your protocol from whatever chain that they're comfortable with, and how to do it securely without relying on like bridges that gets hacked every other Tuesday, right? Like you can just check out, I think it was 2022, which was the year of like bridge hacking. Just go check out what happened with bridges in 2022, and you'll see what I'm talking about. So yeah, I mean, back to the topic. So today the thing is, we are going to dive, or we are going to understand something called Chainlink CCIP. Now, you can just Google it. I mean, Chainlink, yeah, right? I mean, yeah. So we'll be looking into this, and by the end of the day, you'll be able to build applications where a user on, let's say, Ethereum can seamlessly interact with your application on Base without even realizing that they have cross chains, right? So the thing is, CCIP. Yeah, let me just go to their doc. Yeah. So CCIP basically stands for Cross-Chain Interoperability Protocol. I think it's like the naming is pretty convenient. Like it's explanatory. Like you don't have to guess what it does, right? It's basically a protocol. It's basically a cross-chain communication protocol. And the thing is, it's actually one of the most robust solutions for cross-chain communication that exists today, right? So think of CCIP like this kind of a postal service, but for blockchains, right? So I mean, in the real world, if you want to send a package from, let's say, New York to Tokyo, you don't personally get on a plane and deliver it yourself, right? You hand it to a trusted postal service with like international infrastructure, and they have a system to verify the package, track it, and ensure that it gets to the right destination. And once it does, it just confirm, like they confirm the delivery. They might send you an email or message or whatever, right? So CCIP does exactly this, but for blockchain messages and tokens, right? So unlike your actual postal service, it won't claim you were in home when you definitely were, or it won't leave your package in the rain or stuff. It does the job. Like it actually delivers assets and messages from one chain to another. But here's what makes CCAP special compared to many of these bridging solutions that you've heard about, right? First things, it is built using this small company called Chainlink. Now, if you're unaware of Chainlink, I don't think you guys are. So Chainlink is one of the biggest, in Oracle platforms in Web3, right? It's the same team that provides. I mean, CCIP is built by the same team that powers a massive percentage of application with real-time data, especially DeFi, like with price feeds and stuff. So these folks know a thing or two about being secure and reliable, right? I mean, when billions of dollars depend on your infrastructure, I mean, billions of dollars depends on your infrastructure not screwing up. You tend to be really good at, not screwing up, right? So the thing is, when they built a CCIP, they followed the same suit. Like CCIP uses multiple layers of verification, which actually includes a risk management network that acts as a secondary security layer, constantly monitoring for anomalies. Like, so it's sort of like having a postal service with I don't know, multiple independent security teams checking every package, plus a special team that watches the other team to make sure that nobody is slacking off or doing anything funny, right? I mean, paranoid. I mean, does it sound paranoid? Yeah, maybe, but is it secure? Absolutely, right? So this whole thing, this whole protocol is live and it is actually battle tested. And since we are building on main, I mean, base. It's both like both in base mainnet and base Sepolia both support CCIP, which means you can just like after like talking about how this whole thing work, we can just go ahead and start building our stuff. Like we don't have to. It's just smart contracts with a few extra steps added, so you don't have to do any kind of configuration or anything. It's pretty simple. So once we talk about how this whole CCIP works, we can just go ahead and see how it works, like create a contract and maybe send a message across chains. So yeah, let's see how CCIP actually works. All right, so let's just walk through what actually happens when you send something across chain using the CCIP, right? So understanding this will okay, yeah. So understanding this will help you build better applications and also debug issues when they come up. I mean, it will come up, like it's part of the learning process. So yeah. So the thing is, um, like we'll follow a real scenario. Like suppose somebody is sending like 100 USDC from I don't know Ethereum Sepolia to base Sepolia or vice versa, right? So everything begins with something called as the CCIP, like a router contract, right? So which sits on the source chain. So in our case, it can be base Sepolia or Ethereum Sepolia, like whichever you choose. So whichever is your source chain, there we will have like there are a couple of supported chains, like we'll go through it. But in your source chain, there will be something called as the router contract, right? So the router is basically the front door to the entire CCIP system. It knows how to handle your request, like figure out where it needs to go and kick off the whole cross chain process, right? So what happens is your smart contract on your base chain, let's say it's Ethereum Sepolia, it will call the router with all the necessary details, like the destination chain, which is base Sepolia, the receiver address on the other end, the tokens you're sending, if you're sending tokens, and optionally, it also allows for any custom instructions that you want to include. I mean, the last part is actually pretty interesting because you can include instructions for what should happen when the token arrives, right? Like maybe mint an NFT or trigger a DeFi strategy or update some state in your contract. You can encode all that in the message, right? So this is what makes CCIP really cool. I mean, it's programmable cross-chain infrastructure, right? So the thing is, but before all this can happen, you actually have to handle the payment, right? I mean, nothing in life is free, so why should cross-chain messaging be free? Right? So it is also not free, and it makes a lot of sense when you think about it because I mean there is a whole network of Oracle nodes that needs to pick up your message, verify it's whether it's legitimate, reach consensus, and deliver it to the destination chain and all that work. So these nodes are not running on hopes and dreams, right? They are running on real infrastructure and doing real computational work. So you have to pay for it, right? So CCIP actually gives you two payment options. You can either use Link, which is like Chainlink's native token, or you can use the native token of, or native gas token of your chain, which is like ETH for Ethereum, Matic for Polygon, whatever, right? So the router handles both seamlessly. Now, for our example, we'll be using testnets like the Sepolia and Base, so they have link like test links and stuff. So yeah, we'll use that. Now here's something important for building like a really good user experience, because the thing is you can actually estimate the gas fee before you send the transaction. Okay, so I mean there is, based on the thing that you're actually trying to transfer cross chain, there is a function called get fee that tells you exactly how it will cost, right? How much it will cost. So I mean like, I mean, why do you go through all these things? Because imagine, like, I mean, you don't want users to approve a transaction only to have it fail because they didn't have enough tokens to cover for it. Like I said, it's just good user experience, right? Otherwise it will be frustrating for everyone. So check the fee first, make sure that the user has enough, and then proceed. I mean, your user will basically thank you for this because it's a good user experience, right? So now, when you send the tokens cross chain, or when you're sending the message cross chain, the thing is, like, if you're, especially, I mean, this is for tokens, okay, this is for tokens. Like, if you're sending tokens, it's not for messages, right? So when you're sending tokens cross chain, they don't just magically teleport from one blockchain to another, right? I mean, that's impossible. There are complex separate network with their own ledgers and configurations and whatever. So what happens is, instead, like, CCIP uses something called lock and mint. Okay, the lock and mint mechanism, right? For our USDC example, here's what happens. So on Ethereum Sepolia, what happens is, when you're trying to send 100 USDC, your 100 USDC gets locked in a CCIP smart contract, right? The tokens aren't destroyed; they're just locked away, unable to be moved, right? Think of it like putting money inside some kind of a safety deposit box, right? And on your destination chain, which is base Sepolia, an equivalent amount, which is like 100 USDC, is either minted from scratch or released from a pool of locked tokens, right? The key insight here is that the total supply of USDC across all the chains will remain constant. Okay, like, the amount in circulation will always remain a constant. You're not creating new tokens out of thin air, you're just redistributing existing ones, right? Like, if you look at an analogy, like, imagine you have $100 in your bank in New York, and you're traveling to London and you want to access that money, right? The bank doesn't physically ship your dollars across chain. Instead, they will lock your $100 in New York and give you access to 80 pounds or whatever the equivalent is in London, right? The total amount of money hasn't changed, right? It's just been represented in a different place, in a different way. That's essentially what happens with your tokens, right? Conversion, like, there is a conservation of supply, which, like, there is that conservation of supply where you just distribute, which is just distributed across multiple chains, right? So once your chain yeah, sorry. So once your chain hits the router contract and the payment is all sorted out, it gets picked up by the Chainlink's decentralized Oracle network. Right now, this is where all the work happens. I mean, they aren't just random computers running, somewhere. This is the same Oracle network that secures like billions of dollars in different protocols, including DeFi. I mean, the track record here is like track record of this network is quite impressive. Like, no hacks, no exploits, just super reliable infrastructure that has been battle tested in production environment for years, right? So the Oracle network reads your message from your source chain. It verifies everything. Multiple nodes independently confirms that this is a real transaction, not a fake message, not a replay attack, not someone trying to exploit the system. And once enough nodes have agreed on what the message says and where it needs to go, they rely to the base Sepolia network, right? And we already talked about this, right? But apart from doing all this, there is also an extra layer of security called the risk management network, which runs parallelly to the main Oracle network. So if the risk management network detects anything suspicious, like unusual transactions, weird amounts, anything that looks like it could be an exploit, it will pause the operation, right? I mean, this is actually crucial because most bridge hacks, like, if you read about the hackings that happens on, like, the exploits that happens on bridges, it happens when there is a single point of failure. Like, someone will find a vulnerability in the validation logic or something, and they will just exploit it and drain millions before anyone notices, right? So CCIP, it has redundant security checks built in from the ground up. Now, this is one of those architectural decisions that might seem like an overkill until you need it, right? Or until your whole thing gets hacked, right? And in an industry where bridge exploits have cost, I mean, millions of dollars, it's actually kind of better to have that extra security layer working quietly in the background, rather than not having anything like that at all, right? So the thing is, when your message arrives on the base Sepolia, which is like the destination chain. The off-ramp contract basically receives it and handles the delivery, right? So for simple token transfers, this is pretty straightforward. Like the token gets unlocked or minted on your destination chain and sent to whatever address you have specified. You don't even need to deploy a custom receiver contract. Like like the CCIP can just send the tokens directly to any address, like a wallet, a multi-sig, another smart contract, whatever. But if you are executing some custom logic when the token arrives, then you can deploy a receiver contract that implements a function called CCIP receive. This function will automatically get called when your cross-chain message shows up, and you can basically write whatever logic that you want inside it. Right? It can be maybe mint an NFT when the token arrives, or like I said, whatever. Write a state, swap tokens, update or send back a message or emit events. All these kind of things. Right? So the thing is, the flexibility here is what makes CCIP really, really powerful. You're not just moving tokens or sending messages, you're triggering programmable actions across chain. And that basically opens up a lot of possibilities, right? So once you send, there is also this tool. Like the thing is, like once you send a cross chain message, you're not completely sitting blind, okay? You can actually watch it. Like there is something called the CCIP Explorer. Oh, sorry. You can just go here. This is like really, really useful. You can see these messages coming in, right? All these kind of things that is coming in. So the thing is, once you send a cross-chain message, this tool, you can paste your transaction hash, and you can see when this whole message is actually picked up by the source chain, and when the Oracle network is processing it, and when it's being delivered to the destination chain, and when it is finalized and complete, right? This visibility is incredibly helpful during development. Like instead of wondering whether your transaction worked, or at what stage your transaction is, you actually see your message in the pipeline, right? So when something goes wrong, during development, a lot of things go wrong. Like the CCIP Explorer will show you what exactly happened. Maybe the fee estimation was off. Maybe the receiver contract, reverted. Maybe there was an issue with the token approval. Whatever it is, you'll be able to diagnose this whole thing much faster because of the Explorer, right? So that is the general picture. Like when you look at it, you have the router contract. You from your source chain, you access it, you send your message, it goes to the Oracle network, which has the risk management network running the security. Then via the off-ramp contract, you can receive your tokens or message in the destination chain. So yeah, so that's how CCIP works. Now that you understand it, let's just go ahead and build this contract and see it in action. So yeah, let's go. All right, now that we have covered all the theory part regarding the Chainlink CCIP, let's just go ahead and create a small demo, right? So this will be a very simple cross-chain messaging demo where you have two contracts that are sitting in two different chains, and we will send a message from one contract and it will be received on the other. So since we are building this whole thing on base, our source chain will be base Sepolia, and the destination chain will be Ethereum Sepolia, or the Sepolia network, right? So and we'll be building contracts. So I think like we don't have to use fancy frameworks. Like if you want to use, you're completely free to use it. I think I'll just stick to a remix. Which is fairly good for this particular demo. I don't think there will be much complexities or configurations involved, so we can just use Remix. And then another key thing that you need is you have to make sure that you have MetaMask installed. And in MetaMask, like you will need to have all the networks added. I think like Ethereum Sepolia comes by default. Like you don't have to do anything. Like I think it's there. Like you just have to activate the test networks or something, and you'll just get it. You don't have to do anything else there. There is I think it's in advanced, maybe a smart transaction. Yeah, show test networks. Yeah, once you switch it on, you will get all the popular test networks, which includes Ethereum Sepolia. For base Sepolia, the quickest way to add it would be to just go to the base Sepolia Explorer. I mean, you can add it, like you can find all the information by just Googling it. But the most easiest way is to go to the base explorer, and there is this button down below. Just click on it, and it will add all the details to MetaMask. So I've already added it. So that's why it's say showcasing that. I mean, it's showing that alert. But if you haven't added it, it will just add everything to MetaMask. You don't have to add any, or you don't have to type in any information or anything. So once you have those things, we also need the Chainlink link tokens and stuff. Like I'll show you how to get it, but maybe down the line. But for now, make sure that both, like for both your network accounts, like since we are using one account, we'll be just switching the networks. We need to make sure that we have the testnet tokens. Like we need to get a faucet, and we need to get the testnet tokens for both our base Sepolia account. I mean, both our base Sepolia and the Sepolia network accounts. Like we are using the same address, so it's fairly easy. So what you can do is just go to the Coinbase developer platform. It has a very generous faucet. You can just you can just go to the wallet section, faucet. You can see the base Apolia, right? You can just go to this, place the address, and get the token. You can get more funds. You can just go to Ethereum Sepolia, right? You can go to Ethereum Sepolia and do the same thing. So here, if you go to the chain, like if you go to tokens, okay, I don't know why it is not coming, but okay, right? You have this, and then I believe I have the base Apolia. Okay. You can see I also have some link tokens, but I'll show you how to get it. But you also have some, the ETH, right? So the native token. So this will help. Like we need both of this in order to get started with the whole building part. So once you have this, let's just go ahead and start working on our contract. Now, like I said, there will be two contracts. One will be the sender contract where we send the message, and the other one will be the receiver contract from where like we will receive the whole thing. So it's again, like the thing is, like both of them will interact with the router and the offloading contract and everything. Like everything is already preset. Like you can go to the Chainlink. Wait, I'll show you the docs. Chainlink CCIP docs. Yeah, you can see the tutorials, EVM tutorials. I think uh, there will be transfer tokens, transfer messages. Yeah, so there will be addresses that are already available. Like you can just go to these tutorials, and you can actually see different addresses. I believe there will be tools and resources, explorer, manager, token manager, network specific. Yeah, just go to the network specific ones. I believe, yeah, I forgot where they keep all the addresses. Hmm, EVM. Yeah, so you need all these things. You need the link tokens. We will see how to get the link tokens. It's pretty simple. You can see that they also use Rebix, which is fine. And so yeah, I guess like Ethereum Sepolia, like they have the selector. Like I'll show you tell you what the selector and everything is. So for every chain there is a selector ID, which we will also use. But yeah, the thing is there is an address for the router and everything, which I'll show you. But yeah, so generally it's about these two contracts. We'll just go ahead and create these contracts. And the thing is, like I said, like each CCIP, for each chain, CCIP has these unique identifiers, right? So it's for base, it's like a long string, like I think string of numbers, like we already saw one somewhere. Yeah. So this is the identifier for, I believe, Ethereum Sepolia, right? Yeah. So you have something similar for base also. So it's basically a long list of, long list of numbers which identifies each chain uniquely. But we need that. Like we won't say that, send this message to base Sepolia. We will just put in the chain selector. It's called the chain selector, right? And also each chain has the router address. Like if you go to base Sepolia and if you paste this, I have the addresses here, so you can Google it. I mean, it's pretty it's there. So if you, yeah, so this is the address. Like you can see the contract creation and everything. The router.sol, right? So this is the router address in base Apolia. You can just change this. You can just go to Etherscan. Oh wow, sorry about this. And change to Sepolia. And you have a similar address in Sepolia, which is basically the router for this chain. Yeah, you can see again the contract, it's router, right? So yeah, so we'll be interacting with this contract. Like we'll build this contract and we'll interact with it, and we'll see how to use the link and everything. So yeah, so let's just get started with the contracts, right? So let me just go to Remix IDE. Yeah. So this is Remix, and we are going to use Remix, like no fancy frameworks this time. We'll just use Remix. Okay. Now what happened to Remix? Okay. Here it is. Okay. Right. So I'll just create a new folder. I'll call it cross chain. Okay. So I'll just create two contracts. There will be the sender.sol and oh, sorry, did I create a folder? I meant to create a file. Sorry. Cross chain .sil. Oh, what am I doing? I mean sender.sil and receiver.sil. Okay, so these are there. Now we will be deploying both of these things to two separate chains. Let's just go ahead and start with the sender. So we'll create the sender chain first, and then we will start with the receiver. So the sender, since we are using base Apolia as our source chain, we will deploy the sender contract to base Apolia, and then we'll deploy the receiver contract to Ethereum Shipolia, and we'll have function to send and receive message. So yeah, let's get started with the sender contract. All right. So yeah, let's get started with the center contract. Now, the idea of the center contract is pretty simple. So it will send a message using the CCIP, or the Chainlink's cross-chain interoperability protocol, and it will be deployed on our base Sepolia, and it will allow only messages, right? Like we are focusing on messages and not tokens. Like we can make a few tweaks here and there and actually send tokens, but for now we will just focus on messages, which I think is the more cooler thing, because you can get the message on the other end and it can trigger something else. So it's kind of fun. So what you have to do is, once you write the contract, you deploy it, and then you fund it with some link tokens, because in order for it to send these messages, it needs link tokens, right? So which is basically used as the CCIP messaging fee. Now once you have those up there, then basically the owner calls the send message function with all the details, like destination chain, receiver address, and everything. So the contract, like via the interfaces and stuff, like the contract will talk to the Chainlink CCIP router contract to build and send a message, like in a structured format, right? And then the decentralized Oracle network will transfer the message, and on the destination chain, we'll have a receiver contract which will handle the incoming message, right? And you can also add functionalities to act on that message and stuff. But yeah, I'll show you how to send and receive the functions, right? So let's just go ahead and get started with the basics, which is, of course, the pragma. Okay, so we will be using 0.8.0. Yeah, oh, sorry. Right. So, okay. So the thing is, before we get started, we have a couple of imports. Like I'll directly do it. Like you know, so these things are like the CCIP contracts. Like you can just go to the chain link. You can basically Google it and it will show you the GitHub repositories. Uh, yeah. Okay. Okay. Let me just try a more direct approach. Yeah. There you go. So yeah, so we are basically oh, this is the older version. What is the new version? Yeah, the thing is these where is the new version of the chains again? Oh, okay. But yeah, you can find it like these things are always available on GitHub. You can check it out. I think you can directly go here maybe. Hmm. Yeah, it's somewhere there. You can just check for it. So yeah, so the thing is, you have the whole Chainlink contracts, available in the library. You are taking the router client interface so that you get an idea of what are the functions in the router client which you can access. You have similarly something called as the client library, the ERC21. For the tokens like the link tokens and stuff to access those things. The ownable, which is basically a general open zeppelin library to put in some access control. So yeah, let's just go ahead and create our contract. So we'll say contract, we'll call it CCIP sender because it's sending via CCIP, and we'll just say ownable. Pretty standard stuff, right? We are just creating a contract and we are saying that it inherits the ownable. Now next we'll just say I router client, and it's going to be private, and we'll just say immutable. Oh, sorry, immutable, and we'll just call it I router. So immutable means you can initialize the values once, right? And like a constant where you have to put the value right then and there. Immutable allows for you to actually set the values in the constructor. Usually it's in the constructor, but the general idea is you get to initialize the value once, right? And once that is initialized, you can't change it, right? So we have added the client, iRouter client. Then we'll just see the other interface, which is like the ERC20 interface, and we will again put it as private and immutable, and we'll just say oh sorry, I link token. So this will be the interface that helps us access the link token, right? Now, yeah. So another thing that we can do is, okay, maybe we can set up a message like event so that we know when the message is sent. We'll just say message send. We'll put up a few things like Pi32. It is going to be the message ID. Yes. What else? Uint uint v64. We'll just stick to 64, and it will be like it is also indexed now. Indexed parameters. So these help you quickly filter out different events. Like index parameters means just like the tag suggests, they help you index these events. So these will be like the key selectors when you're filtering out these events. So you can index it, or you can filter out using message ID or the destination chain selector, which is a uint64, which can fit in like uint64. So you can say address receiver. I mean, receiver. Okay. And what else? String message. Okay. What else? Okay. We went to 56 and maybe an idea about the fee. Okay. So these are the events, or this is the event that we are going to send. And the next thing is we need to set up a constructor. So the constructor is going to be pretty simple. We'll just say address. Yeah, I think it's filling up pretty quick. We'll just say address for the router. Okay, so we need to provide the address for the router contract and the address for the link token. So the link token also exists both in the Sepolia network and the base Sepolia. So we need to provide the address there so that we can check the balance and all those things, right? So yeah, so that is there. And since we have given honorable, we also have to honorable message. Oh, sorry, sender. Okay, so this basically sets up the owner of the contract, right? So yeah, so now I guess yeah, this is the next step where you say that okay, we have initialized the instance with the address, so that now this using the iRouter we can call the functions. Same with the link token ones, right? So we have set up the whole thing, and next I think we need to send a message to be received on the other blockchain. So it's pretty simple. Like when you look at the whole thing, so we'll create a function called send message. So this is sort of like the core of the contract. Like we can set it to be only called by the owner. It basically helps you format the message in the correct form so that you can send the message across. Right? There is something called the EVM to any message object. Like I'll show you how to create it. It's pretty simple, and it takes in all the parameters like the receiver and data and the token amount and all those kind of things. And yeah, we'll see how to use it and send the message. So let's. I guess we can. Yeah, let's and we can also see how we can just use the like since we are sending the message, I think we can also see how to use the gas fee thing, right? Like using the router contract itself, we can get an estimation of the gas that is required, and we'll just check if there is enough gas to send this whole thing, right? So yeah, let's just go ahead and create the function for it. Sorry, we'll just call function send message, and we have a couple of parameters we need. So one is going to be Win256, or okay, Win64, and we'll call it what destination. Just copy this. So yeah, so this is going to be the first one. Then address. This is going to be the address, and string call data message. So these are the things that we need, right? These are the things that we need, like in terms of the function. Like we need the chain selector so that we know which chain we are sending it to, the address of the receiver and the message, and it's going to be an external and only owner. See, now this is inherited from the owner contract, and it's going to return something. We can actually get the byte ID. I mean, the message ID. So byte 32 message ID. So this we can use this in our Explorer and stuff, and see the whole status, like the transaction ID. We can use the message ID to verify this on the other end, like on the receiver end and stuff. So yeah, we'll just return the byte 32 message ID. So yeah, so the next part is so you have the client, right? So using this we can actually create the object that we are going to send. So what we are going to do is we are going to say client dot yeah EVM to okay any message, right? And we are going to create a new object for it. So we are going to say AVM to any You can just follow any message, right? So we're going to create that object. So what we're going to say is client dot evm to any message, right? So this is oh sorry. I mean, yeah. So within this, we can give a lot of these things, which includes the receiver, which is so we have to ABI encode it. So ABI dot encode the address, which is like the receiver address, right? So that is the first thing. Like we need to provide the receiver. The next is data. So we're going to give API dot encode, and there we are going to put the message, right? And next we need to provide the token amount, token amounts. So yeah, so this is basically for the amount of tokens that we are going to send. So since we are not sending tokens and since we are just sending the data, we'll just say new client dot evm to token amount is going to be an array of zero. So we are not sending any tokens, so the array will be empty, right? So the next is like extra arguments. So we'll say extra args, which is going to be uh, client dot args. Now if you're thinking how I remember all these things, you can just go to this tutorial. It's everything is here. You can see all the things. Like I think this is the receiver. Yeah, there you go. All these things that I've just said is basically here, and I'm just doing this, right? So yeah, that's how. Like once you write the contract, it's pretty easy to see how everything comes together, right? So I'll just say client dot evm extra, sorry, v1. Okay, and we'll just say gas limit. Yeah, we can put that gas limit there. Okay, and what else? So we have that, and what else are we missing again? Yes, we need to set up the fee token. So yeah, I mean it's already there, so that's fine. So the fee token basically, it's we are just setting it as link or the native token. So the thing is, yeah. So once you have these things, oh wait, okay. Uh, oh, sorry, returns. Okay, so yeah, yeah. So I've been like I said. So the fee token basically asks like which token that we are going to use as the fee. Like we are using link, we are not using the native one. So yeah, you just have to give the link's address, which we will get via our constructor. So yeah, like we have the whole thing here, so it's fine. So yeah, now that we have this, we can see how we can use the get fee, right? So it's there in the like we can basically use the chain selector and the message object that we have created, like the EVM message, like EVM to any message object that we have created, and we can actually calculate the fee. So it's like u into 56 fees equals I router, and yeah, sorry, I router dot get fee, and we'll just say destination and the EVM to any message. So this basically gives us an idea of the fee, and we will just say if fee greater than I link token dot balance of address dot this, right? So we are checking if we have the right balance, like the contract has the right balance of the token. We'll just say revert. If it doesn't, yeah, like if the fee is greater than, I think, is it fee or fees? Yeah, it's fees. Sorry. So if the fees is greater than the balance, then we have to revert, right? We don't have enough balance, so we'll just revert the whole thing. So we'll just say revert, not. I think. Okay, we can create a custom error here so that it's easy. We'll just say error not enough balance, and we can say uint 256 256 current balance and uint 256 calculated fees, right? So this gives in case like we don't have enough link tokens, it will just send us the error, so we can just say not enough balance. So yeah, I mean, this is much better. Like I create like these custom errors. So yeah, I mean, custom errors means like for all these things you can set up different errors. So we'll just use that, and I'll just say I link token. Yeah, I mean it completed it, so it's fine. So yeah, so if there are not enough fees, we'll just revert back the whole thing. Else, we will approve the the transfer of tokens. Like we have the whole fees. We got the whole fees and stuff. So we will just approve the transfer of the link tokens on the contracts behalf to the router, right? So we'll just say I link token dot approve. We are approving to this address, which is I router. What is router? Yeah, and the fees. Yes, there you go. So yeah, so we are just approving the whole thing, and we will. Okay, so the next thing is we just have to send the message. We will just say, so once we approve the token transfer, we'll just say message ID equals, what is the message ID? We can say I router dot CCIP dot send. So there is the function send, and we just say destination chain selector and EVM to any message, right? So this is it. We have set up the whole message. This is how you just send the message, and we can just say emit message sent, and we can put up the whole thing. So message ID, what else? um, Destination chain selector will be destination chain selector. Isn't that the name? Yeah. Okay. Or wait. We don't have to give it. Sorry. Yeah. And yeah. So for the third one, the receiver, the message, and of course the fees. So yeah, so this is basically what it is. It's pretty simple. You just create the EVM to any message object, and once you have the object, you create the fees. Like you use the get fee to check the fees, and you see if you have enough fees like balance, and you approve the transfer of the fees, and you get the message ID, and yeah, that's basically it. And you will just say return message ID. Yeah, of course. Yeah. So yes, what is the issue here? Oh, it's bytes 32. Sorry, it's not byte 32. Bytes 32. Oh wait, it should be message again. Since we are using the underscore everywhere, we'll just use the underscore. So yeah. Oh yes, yes. Why do I keep forgetting all these things? Oh, did I misspell it? Oh, okay, sorry. Okay. Right. So yeah. So this part is done. Now, if you do a quick control S, you will see if there is any other issue. Else, you will see the compiler completely compiling it. Now we will have two simple functions. Maybe one that allows, since we are putting link tokens there, we can actually have a function called withdraw link. I mean, this will be address owner or beneficiary or whatever. Uh, External only owner, right? So this basically sends back the link token, so you don't have to go to the faucet every time. So you'll be like u into 56 mount equals I link token, sorry, dot balance of, and we'll just say address dot this. So we'll get the address of this thing and we'll just transfer it. I link token dot transfer, and we'll just say owner and mount. Oh, why am I? Okay. Next, we can also have a function to get the link balance. Function get link balance, link token balance, external view returns event 256, just so that we have an idea. Return I link balance of address to this. Yeah. So this is basically the sender thing. Like, you have the send function, you have a constructor which takes in the router address and the link token address, and you have the sender function which takes in the chain selector, the receiver's address, which is the contract address of the receiving contract that we're going to deploy, and the message, which can be anything, right? And it will just send this whole thing. And yeah, we have a couple of additional functions. So this is basically going to be our first contract. Now let's just go ahead and write our receiver contract, right? Yeah. So let's go. Now that we have created the sender address, let's just go ahead and create the receiver address and then deploy both the contracts onto different chains. So yeah, to start with, let's just go ahead and do pragma greater than 0.810, and of course, like all the typical imports that we did. I mean, here there is a bit different import. Like here it was the router client. So here it's going to be the receiver. Okay. So yeah, so it's going to be the receiver contract, and yeah, rest is basically the client and the honorable, right? So yeah, so let's just go ahead and write the contract. So contract, we'll just say CCPIP. I mean CCIP receiver contract is ownable, and yeah, we'll just say bytes 32 private. I will just put S. So we'll create a couple of variables to actually store all the message details like the message ID, the text, the chain selector, and all those things. So we'll just say, um, yeah, S last received message ID. What else? String private last received text event 64 private last chain selector and address private, yeah, last received sender. So yeah, so these are like oh wait, what happened here? Okay, yeah, the constructor thing. Okay, we'll get to that. So these are some of the details that we will receive through the message. So we'll just get that, and we'll just also put an event message received, and we're going to say bytes 32 indexed message ID UL2 UL64 indexed source chain selector, right, and address center, and what else, string message. So yeah, a basic event so that we know what are the things that we have received, or we can just pass on the message to some, or pass on the information to any other like friend and stuff. So we'll just do a constructor then, constructor address router, and yeah, so we'll just put, so this thing needs yeah, so CCPIP receiver, let's say router, and yeah, so ownable message dot sender. Okay, so here we don't need to initialize anything. Yes, what is this? Okay, so yeah, yeah, we will get to the functions so that it knows. So yeah, so the next one is like we need the function CCPIP receive. So this is already a function inside the CCPIP. Why do I say CCPIP? I mean CCIP receiver class. So I mean contract. So we'll just override it. So we'll just create a function CCIP receive, and so for this we need client. So we are expecting a client dot any to EVM message, and we'll just put memory, and we'll say any to EVM message. So yeah, so this is what we're expecting in the function, and yeah, it's going to be internal, and we are overriding it, right? Because this function already exists in the contract, so we're just overriding the function. So we'll just go ahead and add all the things. Last received message ID. Oh, sorry. Last received message ID is going to be any message, any EVM message dot message ID, right? Then S underscore chain selector, equals any mess dot anonymous into message dot. You can see that, right? Source change selector. Uh, yes. Sender equals sender. What else? Bytes. I'm sorry, what? Okay, yeah, yeah, of course. So yeah, so this has to be decoded. I mean, yeah, sorry, because if you remember, like we actually encoded it while we are sending the address and the text, so we have to decode it before we actually store it to the address. Yeah, it's yeah, and we'll say that it should be address, right? So same thing has to be done with the text, last received text. So here also we'll have to say abi.decode, and the first argument is going to be any2 EVM message dot data, and yeah, it's the string exactly. So we'll just delete the rest. Okay, so yeah, since we have put in since we have added the whole encoding on the other end, we have to decode it before we can use it on this end, right? So yeah, this is basically it. Now we can just emit the event. So this is how we basically receive it. Like everything is handled by the receiver, CCIP receiver. We just have to get the messages. That's it. So we can just go ahead and emit message received. Yes, I think, yeah, message ID. Yeah, we can just say last received or editor message dot. Yeah, I mean s dot last message received ID s dot change selector s received sender, and of course s underscore. Why do I keep messing up the names? And yeah, so this is it. Then we can get the details directly, like we can put a message like we have received all these things. Now we can just create a function, call it get last received message details, put it as external view, and it returns a couple of things, like bytes 32, message ID, what else? String, memory, text, um, event 64, source chain selector, and address sender. Okay. Oh, wait. Okay. Yeah. So this is the function. So we'll be returning all these things, and we can just say return all these things, right? I mean, we'll just say the message ID in that order, right? So s dot text, what else? S. Why do I keep saying dot? It's underscore. Selector, and of course underscore sender. So yeah, so this is it. This is our contract. Now if you just do a control S, is there any error? Yeah. Oh, sorry. Okay, so yeah, I mean, there are no errors. So let's just go ahead and try and deploy both these chains and see what happens. Now, there are a couple of steps that you need to do. Like the first thing is make sure that it's properly compiled. And so since we are putting it on Sepolia, make sure that it's Sepolia 8, like everything is set to Sepolia. Like you have like a pretty cool option. Like I'll just go to the environments, go to wallet connect, which actually connects to support. Like I can just say, where is base support? Okay, so it will just connect to base support. I mean, it will just take the wallet from, yeah, it's pretty neat. I love it. So, yeah. So now you can see that the router, you need the router and the link token address. Now, there is, like, I finally figured out where you can get it. So, there is something called the CCIP directory. You can just scroll through it. You can see base and everything, and it gives you all the things. Like, you can just change to testnet base Sepolia. You can see the router, right? So you can just go and paste the router. Maybe I'll create. So this is the router address, right? Yeah, and what else? Okay, wait. So you have the router address. I think CMOD. There should be the link token too. What's the link token address? Yeah, yeah. Okay, you can see the link token, right? So this is base Sepolia and this is the link token. Okay. So yeah, we will use that fee token, right? So link token. You can store it in like, yeah, I think this is fine because you already have a directory. So make sure that the addresses are proper and you're connected to Sepolia testnet, and you can just click transact and make sure that your contract is basically the sender contract, right? Not the receiver contract, the sender contract. And it's like, yeah, make sure this one is properly selected, right? And then just click transact. Let's see what happens. Yeah, of course, we have to confirm it. And yeah, so there you go. So we'll just store this somewhere, maybe in the contract itself, or we'll just create a new file, maybe. Yeah, we'll just create a new file. Contracts.md. Yeah, and we'll just say, what is this? Sender contract address, and we'll just paste it. Okay, so this is the contract center contract address. We will use it. We will have to use it in the coming things, like when we are sending messages and stuff. So let's see how this happens. So yeah, so now we have the sender contract. Now we will send the receiver contract. So for that, we need to switch the network. We'll go from base Sepolia to Sepolia. So here we'll go in a browser extension. We need the Sepolia testnet, and it will automatically change to the Sepolia testnet. And we have to make sure that we are clicking on the receiver, right? The cross-chain receiver, and we need the address for the router. So again, we will just go here. We will go to testnet, Ethereum Sepolia. Where is Ethereum Sepolia? Oh, okay. So there is Ethereum Sepolia. There is the router address. We'll just click it. You can just click on it and you will see the router. You can see that, right? I think I've already shown you this. Yeah. So we'll just copy this, sorry, router address, go back, put it here, and transact. Again, we are confirming the whole thing, confirm. And might take a while because it's Sepolia and a lot of people use Sepolia, but yeah, there you go. So we have this, so we'll just store it again in our contracts.md. Okay, edit it. We'll say receiver contract address. Okay, so yeah, so these are the two contract addresses. Now let's see how we can send. Now before, okay, so this is the most like, this is an important part. The thing is, you need to add some link tokens to this contract address, which is the center contract address, right? So what you do is you just copy this Chainlink faucet, Yeah, you can just go to the faucet. So we'll just select base Apolia, right? Continue. We'll just copy this contract address, which is D. Make sure it is proper. Verify this whole thing and get tokens. Okay, I think something is happening. So this is actually being sent to our contract, not our wallet. So the only way to verify it is just go to the base Apolia. Okay, both of them are connected. So in order to verify it, what we have to do is go to base Apolia. Is it okay? This is Sepolia and this is Basecamp, right? So go to the Basecamp, like Base Sepolia Explorer, copy this address, right? Copy this address and paste it and see if the token has made its way to the contract. You can see that there is no ETH, but yes, you can see the 25 link, right? So that means our contract has enough tokens. So let's just go ahead and right now we have to interact with these contracts. So go to deploy, we'll just copy this. So first we will send the message. We'll just say wallet connect Sepolia, right? Okay, make sure you are connected to Sepolia, right? Yeah, so you have the whole thing, and I'll just put the address here, which is the sender contract, which is there in our Sepolia. So add address. Okay. Oh, sorry, sender. Yeah. Make sure you select the sender one. Yeah, so that it gets the API. So make sure it's the sender contract, which is 1DE. Okay. Yeah, that is there. So I'll just say add address and yes. So we have the whole thing, right? Oh, did I? Oh, wait. So sorry. Yeah, just make sure that you select the sender one and click add address. And yes, you can see the whole thing, right? The send message and everything. So here we're just going to use the send message. So we need the destination chain selector. So we are just going with our where is the CCP directory. Yeah, okay. So just click on it, just click on testnet. So we need the Ethereum, Sepolia. Yeah, this is the selector. Just so click on it. So paste it here. Now the receiver address is basically our contract address. We'll just copy this, just paste it here, and I'll just say to from from base, right? So yeah, so you can transact and okay. So yeah, so you can see that the transaction is completed. You can see the message and everything that we are sending. Now this might take a while, right? So what you can do is you can copy the transaction hash, go to CCIP Explorer, right? Go to the CCIP Explorer, and you can actually see the status. Like you can just say this, click this, and yes, you can see our whole message. You can see that okay, it is waiting for finality. It's from base Sepolia to Ethereum Sepolia, so everything is good. Now it might take a while, maybe around 5 minutes or something, based on the congestion. So yeah, once this is done, like once this is confirmed, we can go to our other contract, the receiver contract, and basically see how we have received the message. So yeah, let's just wait for the confirmation. Okay, now that we have our whole thing set to success, set to success, that means our message should have arrived at the Ethereum Sepolia. So to check it, let's just go and see what has happened. Let's just go to the receiver.sol. We need the address. So it should have be like this whole thing will be like the receiver contract there would have automatically called all the functions, and we should like the CCIP receive, and it should have all the things set. So let's just go ahead, copy the like receiver contract address, go to this, make sure you are set to this, go to the address, add address, so we'll get the instance. And now if we go to last receive details, there you go, there you go, you can see the message Sedu from base. So yes, we have our whole message here, right? We can see the message ID, the source, the selector, everything is proper. So that means we got, and this is basically the sender, which is the contract address. You can see this, right? So yeah, so that's how, and we have Setu from base, which was our message. So there you go. This is how you basically send message from base and receive it on Ethereum, like base Apolia and receive it on Ethereum with Apolia. Yeah, so we've successfully sent a cross-chain message using CCIP. So yeah, I mean that's basically the whole thing. So it's pretty simple. You just need to know the mechanics of how things work and create a contract around it. Nothing too fancy. And I would suggest like you guys can go ahead and try out the token thing. Like I said, it's just one parameter difference. That's it. So like the document basically helps you get started. So yeah, go ahead, try it out and build some cool stuff. So yeah, see you around.